Bending may seem like a simple task, but it can be tricky. If it's bent the wrong way, you may end up with a crimp in the tube. When that happens, the tube is ruined because a crimp will prevent proper flow through the tube. To do the job correctly, a bender is used. For a lightweight tube, such as a piece of copper tube, a spring bender can be used. Hand benders are made differently to fit specific sizes of tubing. Here's one that will bend this heavier piece of tube. Again, put the tube into the bender, moving the slide handle so the tube fits securely. Then bend it on the mandrel until the desired angle is made. A long-handled bender is usually used for heavy tubing, and for large tubing, a hydraulic bender may be needed. But even with a bender, a piece of tube can be improperly bent. The tube and bender must be aligned correctly, and the tube must be held securely in the bender as the bend is made. Now, this is a good bend. Well, let's look at a few bends that are not right and talk about some of the reasons why the bends did not turn out to be correct. Notice that on the good bend there are no wrinkles, no kinks or flat areas. But on this tube, there are wrinkles here along the inside of the bend. Now, this is usually caused by bending thin-walled tubing without adequate support of the mandrel. A kinked bend also can be caused by inadequate support of the mandrel. Flattening at the bend is caused when the tubing is not securely held in the bender, causing the tube to slip as the bend is made. Tubes must be firmly clamped in the bender to prevent them from slipping as the bend is made. Practice is the best way to learn how to use a bender properly, and it's best to practice with different sized benders and with different weights of tubing. So once the proper bends are made, the tubing can be installed and the new hookups made. At this time, the system should be flushed and a careful check made for leaks in the new line of tubing. Any adjustments that are needed should be made before the system is put back into service. Well, let's watch now as the mechanic measures, bends, and installs a replacement line of tubing in this system. First, he puts the fitting that will attach the tube to the system in place so that he can get a precise measurement. With a ruler, he measures the distance to where the bend will be made and then the distance to where the next bend will be made. The fitting is removed, but it will be slipped back onto the tube to make further measurements as the tube is attached to the system. Now, the mechanic will make the same measurement on the tube. And then he will mark the measurement on the tube. Once the mark is made, the tube is placed in the bender. While checking the angle on the mandrel, the mechanic will bend the tube in the right angle that is required to make the turn. Then he will mark the distance to where the second bend is to be made, and again will mark it on the tube, drawing his line all the way around the tube. The tube is put into the bender once more and tightly secured so it won't slip during bending. Then the second bend is made just as the first one was done. Now he will connect the tube to the system so he can check his work. The tube is connected and the fitting is tightened. The first two bends are fine. Now this time, he is able to use a piece of the old tube in figuring the course of the replacement. The old tube will serve as his guide as he prepares to make the final bends in the new line of tube. Again, the mechanic carefully takes his measurement, making sure that his angle will be correct. Then he removes the old and the new tube and marks the new piece at the pre-measured point, going all the way around the tube. Now, he can attach the bender to the tube, as he has done before, and make the bend. Then he is ready to measure for cutting. The tube is again fit into place. Now he can mark the cutting place for the tube. And to make the cut, the tube is detached. The cut is made with a cutting tool attached at the pre-marked place on the tube. The cutter is rotated around the tube until the cut is made. As before, burrs are removed with a reamer, and the end of the tube is filed to smooth it out. The reamer is used again in case any more burrs were formed as the mechanic was filing the end of the tube. He'll file it once more to ensure a good, clean end. Then, before he flares the cut end of the tube, he will put both of the fittings onto the tube. The die is attached to make the flare and tightened. The flare is made as before with the flaring tool yoke turning the T handle in a clockwise direction. The fitting is then rolled up to the newly flared end of the tube. Now, when each of the fittings is attached to the system, the mechanic tightens them with his wrench, and his job is done. Well, that wraps up our discussion on tubing installation. We've seen that tubing is much more flexible than pipe and can be installed with fewer fittings than pipe. We've talked about various types of elbow and union fittings, and we've looked at how a piece of tube is flared, threaded, or compressed to connect with more tubing or to a component. Finally, we've seen how tubing is properly bent and installed. You'll find that there are many variations on these basic ways to install tubing, so always check the manufacturer's instructions and your plant specifications before you begin your work. Next, we'll take a look at flexible hoses.